Okay, now we're starting functions. A function is a relation where each x value there is a unique y value. We'll give them special names, which we'll go through later. One way to identify if a relation is a function is to perform a thing called a vertical line test, and that's all it is. As the name suggests, we just draw a line down the middle, or anywhere actually, and try and cross exactly as many times as we can. To be a function, the vertical line must cross exactly one point when drawn anywhere on the graph. Functions are usually denoted by lowercase letters. So here we've got an example of y equals x squared, which is a parabola, and I draw this dotted line anywhere, and it crosses 1, so that means it's a function. While this one here, x squared plus y squared equals 4, is a circle, and when I draw my dotted line anywhere, I don't get a function because it crosses more than once. Example 1, if f of x equals 2x squared plus x, find f of 3, f of negative 2, and f of negative 1. Well, that's pretty easy. Wherever I see an x, I put a 3 for the first one. So I get 2, 3 squared plus 3. So I got 2 times 3 squared is 9 plus 3. 9 2s are 18, and 3, 21. F of negative 2, wherever I see an x, I put negative 2. So we get 2, negative 2 squared, minus 2, so I'll get 2 times 4 minus 2, which I've got is 8 minus 2, which means I've got 6. And f of x minus 1, I get 2 x minus 1 squared plus x minus 1. I'll need to expand the brackets. I get 2 x squared minus x, and minus x is minus 2x plus my 1 plus x minus 1, which means I've got 2x squared minus 4x plus 2 plus x minus 1, and when I simplify that, I get 2x squared minus 3x plus 1. Example 2. F of x equals 2x plus 1, find f of negative 2 and f of 1 divided by a cannot equal 0, because if we put a equal to 0, that means it's undefined. So the first one, f of negative 2, gives me 2 times negative 2 plus 1, negative 4 plus 1, which means it's negative 3. F of 1 on a, they should be lowercase f's, but for some reason they're becoming uppercases, plus 1, so that means I have 2a plus 1. Example 3 says, consider the function defined f of x equals 2x minus 4 for all x is an element of rules. Part A, find the values of f of 2, f of negative 1, and f of t. So part A I'll do over here. F of 2 gives me 2 times 2 minus 4. 2 2s are 4. Minus 4 gives me 0. F of negative 1 gives me 2 times negative 1 minus 4. That's minus 2 minus 4 is minus 6. And f of t gives me 2 times 2, so 2t minus 4. That's part A. Part B, for what values of t is f of t equal to t? So wherever I see an x, I'm going to substitute t, and that answer will equal t. So I've got f of t is 2t minus 4, and that will equal t. So when I solve this, I get t equals to 4. And part C, for what values of x is f of x greater than or equal to 0? Well, there's my f of x. That's what that equals, 2x minus 4. So I want to know when 2x minus 4 is greater than or equal to 0. So I'll bring the x across, and I get x minus 4 is greater than or equal to 0. So x will be greater than or equal to 4. Remember, I only change the direction if I multiply or divide by a negative number. And you can do this on your calculator. Okay, f of t, f of 2, and f of all of them. So you should first define the function, and then when you put f of 2 in, you get your 0. When you put in f of t, you get that. You can solve for the t, so f of t equal to t, solve it, and greater than or equal to x as well. Restriction of a function. Functions can be restricted by restricting the domain. Example below is an example of the same function with the domain restricted 3 different ways. So this is the normal one, y equals x squared, and it's all reals. This is x squared, but it's between the x values of negative 1 and 1, and this is x squared, where it's only the positive part. So we can restrict it. Example 4. It says sketch the graph of each of the following functions and state its range. So this one here, f of x, that's just a straight line, but it's only between -1 and 2. So when I draw this, it's easier to draw them. When x is -1, I put -1 in there, I'll get y equals -1. So it starts there. This is my f of x. It's not y anymore, it's f of x. When x is 2, I put 2 in there. So there's 1, there's my 2. I get 1, 2. Oops, there it is there. When x is 2, I get that one there. And it's going to cross at 0, 0. So using my red, it's going to go from there to there. And these are coloured in because of these brackets here. Part B, I've got x squared plus x. And again, it's between -1 and 1. So I've just quickly done that. I know that the parabola, if I put x equal to 0, I get y equal to 0, so it's going to cross there. It's a parabola, so when x is -1, I'm going to get -1 squared is 1 minus 1, so that equals 0. That's when x equals -1. So that's going to stop here. When x is 1, x equals 1, I'm going to get 1 squared, which is 1 plus 1 gives me 2. So I better go 1, 2 up there. That's going to stop there, the square bracket, so it's inclusive. So it's a normal parabola, so it's going to come down here. It's going to start there, be a parabola like this, and come up, come up there, smooth the curve, please, like that. And it's going to stop there, and it's going to stop there. Oh, the range, we've got to do the range. Better go back. So the range of these ones, for this first one, the range, the x value, the y values is from -1 inclusive to 2 inclusive. And for this one here, the range, the lowest value of y. So I'll need to find the turning point, which is going to be when x is a half. So f of a half, halfway between 0 and -1, so -1/2. I get -1/2 squared gives me 1/4 plus 1/2. That will give me, minus 1/2. So I'm going to get -1/4. So the range will be from -1/4 inclusive all the way up to 2. This one here, all right, this is 1 on x. We know how 1 on x looks like. Asymptotes. So this one here, the graph will look like this between 0 and 2. Well, 0, remember, gets closer and closer, but it never goes there. And 2. When I put 2, I'm going to get 1/2. So I'm going to stop it right there. And this value here is 2 and 1/2 for the y. So that's 2, that's 1/2. And there's nothing along the y-axis because it doesn't actually cross there. Remember that one? And D, well, that's just a parabola. I know it's going to cross at 8 straight away. So I'll do 8 there. There's my y. There's my x. Turning point, I can work out the turning point. You guys know how to do that, so I'm not going to do it. But the turning point is at 1 and 7. So right there. So this graph, and it's the main is all rules, so it continues. So this graph here will look something like this. If I can make it go through the y at 8, and something like that. No, excuse that. Excuse the bell. I didn't realise the bell was going to come. The range for this one here is from 1/2, and because it's included, we do it up to infinity. And the range here is from 7 up to infinity, and that will be a square bracket because it's included and not that one. And again, you can define them and graph them on your calculator. That's 6C.